Hi guys, I hope all is well. So today I'm going to talk about equations of lines and planes. So that's section 12.5, equation of lines and planes in the three-dimensional space. Well, so let's start first with the lines, okay? So let's start in 2 dimensions. So in 2 dimension, you have two variables, right? You have my x here and I have y here, okay? And actually, to determine an equation of a line in 2 dimensional space, basically you need two things. You need a point, okay, and so how many lines they pass through this point? Well, of course, there are infinity of lines they would pass through this point, okay. But to fix the line, you need the slope. So so let's say you want to find the line which passes through the point 1, 2. Okay, so let's say this is the point 1, 2, and then we need the slope. So with slope slope equal to 2. Okay, so let's say that will be this line here. Okay, so this line here. So this line here passes through the point 1, 2, and the slope here is 2. Slope, let's say, is 2. So what will be the equation of this line? Well, in general, the equation of a line in 2-dimensional space is given by y equal to ax plus b, right? This is like the general equation of a line in 2-dimensional space. Now, what's a? A here is the slope, right? A is the slope. So in this example, for the slope is equal to 2. Okay, so then y is actually equal to 2x plus b, right? Because the slope a is equal to 2. Now, how can we find b? Well, we know that the line passes through 1, 2, the point through 1, 2, right? So 1 is x and 2 is y. So when x is 1, y is equal to 2. So when x is 1, so when this x here is 1, this y here is going to be equal to 2. So it's going to be 2 equal to, well, here's 2 here, so it's 2 times 1 plus b, right? So that's 2 equal to 2 plus b, and so b is equal to 0. Okay, so the answer here, y is actually equal to 2x plus 0, so that's 2x. So that's the equation of my line here. So here's 1, 2 again, and so we have this line here, right? And so this line here, the equation of this line here is y equal to 2x. But anyway, so the point here is that we need to determine the equation of a line in 2-dimensional space. Actually, we needed two things. We need the slope. So the slope. Okay. So we need the slope and a point. Okay, so once you have the slope and the point of the line, then you can compute the equation of the line. Okay, now what about the situation in 3-dimensional? So we are interested in 3-dimensional space, right? So in 3-dimensional space, to determine the equation of a line, we're gonna need two things. Like it's the same like as in the 2-dimensional case. But we're gonna need actually a point, and instead of slope, so the analog of the slope would be the direction vector. So to determine the equation of a line in 3-dimensional space, we need first a point, okay, and then direction vector. So the direction vector actually play the role of the slope. So direction So the direction vector is like the slope of the line. Okay. Direction vector v. Okay, so it's like, so we are in three-dimensional space, so we have here's x, this is the height z, here's y. So if you have a point, so let's say here's the point, and you know that the line passing this point has direction vector. So let's say here's a vector u. This is a vector u. So direction vector of the line means that actually the line is parallel to the vector u. So it's like so like here in this case, my line would be this one. So the line would be the line which passes through this point here, okay, and which is actually, you know, parallel to the direction of the vector u. So it's parallel to u. So that will be this line here. Okay, so that would be this line here. Okay, so once you have a point and once you know the direction vector, okay, so again, the direction vector means that's a vector which is parallel to the line, okay? This is a vector, so this is a vector which is a vector parallel to the line, a vector parallel to the line. Okay, so how do we find the equation of the line? Well, so let's say the line passes through the point P. Let's say P is x0, y0, z0. Okay, and with direction vector, so again, direction vector is like the slope, so our line would be parallel to this direction vector, and with direction vector u, so let's say u is given by a, b, c. Okay, so let's find the equation of the line. So find the equation of the line. Okay, so how do you find the equation of the line? So we said, so here's your point P. Okay, and here is your vector u. This is your vector u. Okay, so let's say this is the vector u. Okay. So we want to find the equation of this line. So my line passes through the P, my line passes through the P, and it's parallel to the vector u. So here's my line L. Okay, so this is my line L. Okay, and I want to find the equation of course, of the line L. Okay, so how do you do that? Well, the idea is the following. Take any point which lies on the line L, okay, like this point here. I don't know what are the coordinates of this point, so let's call them, they're unknown, right? So let's call them x, y, z. So here, this is x, y, z. Okay, the point P, we said it's point P, it's x0, y0, right, and z0. That's the point P. Okay, so now the thing is, you know that the point P and the point x, y, z, both they belong to the line, right? So if you take the vector, if you take this vector here, which goes from P which goes from P to this one here. So if you take this vector here, which goes from T to the XYZ, okay. So if you take this vector, well, then you know that this vector here, it's actually parallel to the vector u, right? So this one here, so this vector, so this vector here, it's parallel to the vector u, right? So now what are the coordinates of this vector here, this one here? Well, it goes, so the initial point is P, initial point is P, right? And terminal point is XYZ. Okay, so this vector here, which goes from P to the point XYZ, okay, so the vector, so let's call this vector here, let's call the vector V. Okay, this one here, this is the vector V, okay? So V is parallel to U, right? So then the vector V would be equal to, vector V is equal, so you go from P to XYZ, so that will be terminal point, XYZ minus the initial point, which is capital P, right? That's the initial point, so that's X0, Y0, Z0. So the vector V would be the vector X minus X0, Y minus Y0, and Z minus Z0. Okay. Now, you know that the vector V is parallel to the vector U, right? They are parallel. Right? So remember, guys, we said two vectors are parallel if one vector is a multiple of the other vector. So then V is equal to some number. So let's call this number T. So T times the vector U. So T here could be any real number, is a real number, right? Is a real number. And actually, T has a name. It's called the parameter. So T here is, you know, it's just a variable. It's just another name for a variable. So T here is called the parameter. It's called the parameter. Okay. So V, we know that V is equal, you know, X minus X0, X minus X0, Y minus Y0, and then Z minus Z0. That's equal to T times, we said T times U, so U, we said it's ABC, right? So then, that means that X minus X0, Y minus Y0, Z minus Z0 is equal to T times A, T times B, and T times C. Okay, so then my X minus X0 is equal to TA, so X minus X0 is equal to TA, Y minus Y0 is equal to TB, so Y minus Y0 is equal to TB, and then Z minus Z0 is equal to T times C, and then Z minus Z0 is equal to TC. Okay, so in other words, X is actually equal to X0 plus TA, Y is equal to Y0 plus TA, and Z is equal to Z0 plus TA. Okay, so in conclusion is the following. So the conclusion is, So the equation or the parametric, so this equation here, because we are using the parameter t, so it's called the parametric equation of the line. So this is here, this is a parametric equation of the line. This is parametric equation of the line. Okay, so the conclusion is that the parametric equation of a line passing through the point, let's say x0, y0, z0, and with direction vector u equal to abc is actually the following. So you have x equal to x0 plus ta, y equal to y0 plus tb, and z equal to z0 plus tc, where t is as a parameter, so t is a real number, so t is a real number. So here, just to say, belongs to the real number. So this is belong to the real numbers, t and r. Okay. So actually, in other words, we say that the parameter t parameterizes the line. Okay, so let's do an example so we can see how it works. So examples. So example 1. Let's say you want to find the equation, parametric equation of the line passing through, let's say P is the point 1, 2, negative 3, and with direction vector say u equal to negative 2, 1, and 0. So what will be the equation of the, in this case? Well, so here's the answer. Well, so then the equation is the following. So then x, so x is supposed to be x0 plus ta, y is y0 plus tb, z is z0 plus tc. So here, well, this is x0, here's y0, this is z0, and u, the direction vector, that's a, here 1 is b, and the c is 0. So that will be equal to, so x0 is 1 plus t times a, so t times negative 2. Y0 is 2 plus t times b times 1. And z0 is negative 3 plus t times 0. So that's equal to 1 minus 2t. So x is 1 minus 2t, y is 2 plus t, and z is equal to negative 3 plus 0. So it's just negative 3. Okay. So let me just here remark something here. So if you have, so here's my line. Line we said x, here's y, here's z, right? So we said x is 1 minus 2t, so 1 minus 2t. Y is 2 plus t. And z is negative 3. So you see, guys, here the thing is, so let's, if you want to draw, let's try to draw this graph, this line here. Okay, so let's draw this line here. Well, so we are in a three-dimensional space, so we have x, y, z. Here's my x, here's my y, here's my z, right? It's x, y, and z. So the thing, guys, is that for each value of t, you get a point of the line. So for example, if you say, let's say t is 0. Okay, so if t is 0, what do we get? If t is 0, x is 1, y is 2, right? And z is -3. Z is always -3, right? So if t is 0, you get the point 1, 2, and -3. So 1, 2, and -3. So 1, 2, -3, right? So that will be a point of the line. So let's say here's 1. Sorry, this is supposed to be z here. And here's supposed to be y. Okay. So 1, 2, -3. So here's a 2. And here, of course, somewhere here, -3. So let's say you get this point here. So here's the point. This is the point. This is the point. 1, 2, -3. Okay. Now let's say t is let's say t is equal to 1. Okay, so if t is 1, then you get what? Well, you get the point 1 minus 2, so that's -1. You get the y would be 2 plus 1, that's 3. And z is still -3. Okay, so you get this point, -1, 3, -3. So you get another point. So let's say here's a point, this is a point. Let's say this is 1, -1, 3, +3, -3, right? So you get another point. Okay, so you see each time, so whenever you replace t by some number, you get a different point of the line. Okay, so t corresponds actually to the, for each value of t corresponds to a point which lies on the line. Okay, so each value of t corresponds to a point on the line. Right, so for example here, this -1, 3, -3, that's when t is 1. This is the point, so 1, 2, -3, this is when t is equal to 0. Okay, and so the line would be, of course, the line passes through these 2 points, right? Through these 2 points. So that would be my line L. And so what I'm saying is each point of the line corresponds to some value of t. So let's say this point here corresponds to the value t equal to half. This point here corresponds to the value t equal to 2, for example. So each point of the line corresponds to some value of t. So whenever you replace t by a number, you get a point on the line. Okay. Now let's do one more. Let's do more examples. So example number 2. So let's find the line. Find the equation, parametric equation of the line which passes through the two points, through the points let's say p equal to 1, 2, -1, and q equal to -2, 3, and 0. Okay, so here again we are three-dimensional space. So this is z, this is x, this is y, and then you have 2 points. So here this is the point P, and here this is the point Q, and you want to find the line, the equation of the line which passes through these 2 points, right? You want to find this line here passing through these 2 points. Okay, So we want to find the equation of this line here. Again, so guys, here we said to find the equation of a line, we need a point. Well, here actually we have more than one point. We have 2 points, but we need a direction vector, right? And the direction vector here is not given. So how do we find the direction vector? Remember, guys, the direction vector is just a vector which is parallel to the line. So here, can we find a vector which is parallel to the line? Yes. So if you take the vector which goes from P to Q, so if you take this vector here, which goes from P to Q, right, this vector here, so the vector PQ, so this is the vector which goes from P to Q, well, the vector PQ, it's parallel to the line, right? It's parallel to our red line, okay? So PQ would be a direction vector. Of our line. All right. So what's PQ? Well, so PQ is going to be equal to, it's terminal point minus the initial point. So the terminal point is Q, so that's negative 2, 3, 0, minus the initial point 1, 2, negative 1, right? So that will be equal negative 2 minus 1, so that's negative 3. 3 minus 2 is 1, and 0 minus negative 1, that's positive 1. So that's my direction vector. Okay, so now, so the answer, once we have the direction vector and point, so the equation is, or the parametric equation is, so x is going to be x0. Remember, x0 was the x0, y0, z0 are the coordinates of the point. So here, like here, that would be x0. Here's y0, and this is z0. Okay, so x is gonna be supposed to be x0 plus ta, right? The a would be here. So PQ, that's the direction vector. So the negative 3, 1, 1, that would be the ABC, right? So x would be equal to x0, which is 1, plus t times a, so t times negative 3, right? Now y is going to be equal to y0 plus t times b. So y0 is 2, plus t times the b. The b is 1, so times 1, and then finally z is supposed to be z0 plus t times c, so z0 is negative 1, so negative 1 plus t times c, and c is positive 1. Okay, so times 1. So that's the equation of our line. Okay. Here, guys, you can also use the point Q as x0, y0, z0. It's going to be the same thing. So here, so another possible answer so here we can use Q as a point. You know, our line passes through the P and Q, right? So we in our answer we used P as the point, right? Well, we can also use the Q as a point in the equation. Okay, so then x would be x0. So x0 here would be the negative 2 because we are using Q as a point. So x0 plus 2 times, again, the same thing here, a, which is negative 3. Y is equal y0 in Q, so that would be 3 here. So 3 plus t times b, which is 1. And finally, z is equal to negative, so z0 So z0 is 0, right? So 0 plus t times c, and c is positive 1. Okay, so that's another possible answer. So this is negative 2 minus 3t. Here, this is 3 plus t, and this is actually equal to t. Okay, so you may ask how it's possible. How come they're the same answer? Well, that's because you are actually free to change the parameter t. So if you can change a little bit your parameter t, okay, and then if you change a little bit your parameter t, you get a different different answer. But both are actually both equations describe the same line. Okay. So what I am saying here is just if you replace probably t by, so here, if you replace t by, let's say, t plus 1. Okay, so if you replace t by t plus 1, for example, here, negative 1 plus t plus 1 times 1, that would be just equal to t. So we're going to be here, same answer. So if you replace here t by t plus 1, you get the second answer here. Okay, but anyway, both answers are correct. Example number 3. Let's say find the line which passes through the point, let's say P equal 1, 2, 3, and parallel to the line let's say L, given by, let's say L, the line L is, let's say x equal to 2 plus t, y is 1 minus 3t, and z equal to minus t. Okay, so what I'm saying is I have this point P here. This is my point P. Here's my line L. This is my line L. And I want to find the line which passes through the point P and parallel to the line L. So I want to find this line here. Okay, so the question is, what's this line here? The equation of this line here. Okay, so I want to find this line, the blue line. Okay, well, remember guys, to find the equation of a line, parametric equation of a line, you need a point. So this line here passes through the point P, right? So we already have the, so we have the point. That's good news, right? And we need, of course, a direction vector. So now the problem is to find the direction vector of this blue line. Well, remember again, a direction vector, that will be a vector which is parallel to the line. Well, here, this blue line is parallel to the green line, right? So now question, do you know the direction vector of the green line? Well, I know the equation of the green line, right? It's 2 plus t, 1 minus 3t, z equals to minus t. So what would be a direction vector of this line L? Remember, the equation of the line was like x0 plus at, y0 plus bt, z0 plus ct. ABC would be the, ABC is the direction vector, right? That's my direction vector. So what will be the direction vector of the line, the direction vector of this line L? Well, if you take the vector u, so let's say u is equal to 1, -3, and -1. So 1, -3, -1 are the coefficients of t. Right here it's 1t, here it's -3t, and here it's -t, right? So that's -1. So the coefficients of t are the coefficient or coordinates of the direction vector of the green line L, right? And if L has a direction, so if this vector here, U, is the direction vector of the green line, so it's also the direction vector of the blue line, right? Because the blue and the green lines, they are parallel. So if the vector U here is parallel to the green line L, so it's also parallel to the blue line, right? So then, so we know that U, which is 1, -3, -1, is a direction vector of our line. Okay, so we are done, because so then the answer, so the equation of our line would be, so x is equal, so x0, here's x0, y0, z0, so here this is x0, this is y0, this is z0, so x is going to be x0, so it's 1, so it's x0 plus t times a, so it's 1 plus t times a is 1, right? Remember, guys, here this is a, here is b, and here this is c, right? So then y would be y0 plus tb. So y0 is 2 plus t times b, which is -3. And then z is equal to z0 plus t times c. So z0 is 3 plus t times c, which is -1. Okay, so that will be the parametric equation of our line. Parametric equation of our line, of the blue line, right? Well, anyway, guys, I guess I'm gonna stop here, and I will continue next time probably with the second part of this section, which is about actually the planes. Okay, so next time I will do probably one more example about the lines that are actually, you can have like different kind of problems where you have to find the equation of a line, and then we will do the equation of planes. Okay, well, thank you. See you next time.